8D, in this, the before problems are different. The functions are defined in the limits. X is less than 2, 1 is 2 is less than or equal to x is less than or equal to some 3, x is greater than 3. Some limits are they have given, and to find out those function limit values. Here they have given directly the functions which is not defined in the separate particular interval. It is directly they have given, that is nothing but x is belongs to real number set, that is nothing but it is minus infinity to infinity. See here the first solution, limit x tends to 3, limit x tends to 3, x square plus 3x plus 2 by x square minus 6x plus 9. What we have, first we can do the substitution of x equal to 3. When we can substitute the x equal to 3, then it is 3 square, it's 9 plus 3 3s are 9 plus 2 by 3 3s are 9 minus 6 3s are 18 plus 9. It goes to 20 by 0, it goes to infinity. Okay. So here it is infinity. If any other implementation is there, that is limit x tends to 0, we can find out the factors, that is x square plus 3x plus 2. So here x plus 2 into x plus 1. But in the denominator, it is x minus 3 whole square. Why? Because it is x square minus 2ab plus b square. A square minus 2ab plus b square form. So it is in the form of x plus 2 into x plus 1 by x minus 3 whole square. So in this, there is no suitable form if it is not in a power x minus 1, e power x minus 1, and sin x, cos x, tan x. Those are not suitable, just functions they have given. So immediately we can apply the substitution of x equal to 3 only. If any factor, the numerator term is split into factors, if the factors of the denominator, what the factor is reduces to 0 in the denominator, it will be cancelled or not. Just we can check that one. It is not cancelled, just directly we can substitute the value only. If the cancellation is possibility is there, then we can cancel it, then we can substitute. That is the thing. Okay, this is the first solution. The second solution is here also, limit x tends to 1 minus. X tends to 1 minus means that the value is a negative value. So here minus 1 whole square is also plus 1 only. So we can take x, either x tends to minus 1 or x tends to plus 1. That is 1 plus or 1 minus. We can substitute in the place of x equal to 1 only. When we can substitute in the place of x equal to 1, it goes to again infinity only. Limit x tends to 1 minus 1 plus 5x cube by 1 minus x square, it is equal to 1 plus 5 by 1 minus 1, 6 by 0. This is also infinity. In this also no cancellation factors. So we can substitute directly. Okay.
Okay.
The third solution, limit x tends to infinity 3x square plus 4x plus 5 by 3x cube, sorry, 2x cube plus 3x minus 7. Here x
Limit
tends
x
to
tends to 0.
x tends to infinity they have given. If x tends to 0 means we can substitute the 0 value. But x tends to infinity means we know that 1 by infinity equal to 0. So in that case, we can take the highest degree term of the x in the numerator and denominator common. That is x square into 3 plus 4x by x square plus 5 by x square by x cube into 2 plus 3x by x cube minus 7 by x cube. Here x square power get cancelled. It is equal to limit x tends to infinity 1 by x into 3 plus 4 by x plus 5 by x square by 2 plus 3 by x square minus 7 by x cube. Now we can substitute in the place of x tends to infinity means 1 by x equal to 1 by infinity, it goes to 0. So this is equal to 1 by infinity 3 plus 4 by infinity plus 5 by infinity square by 2 plus 3 by infinity square minus 7 by infinity cube. It is equal to 0 into 3 plus 0 plus 0 by 2 plus 0 minus 0. 0 into something is 0. It is the solution. Fourth solution, limit x tends to infinity 6x square minus x plus 7 by x plus 3. In this case, if x tends to infinity is there, the same rule, we can take the highest power of the x term, that is x square into 6 minus x by x square plus 7 by x square by x common 1 plus 3 by x, x cancel. It is equal to substitute infinity, infinity into 6 minus 7 by infinity plus 7 by infinity square by 1 plus 3 by infinity. It is equal to infinity into 6 minus 0 plus 0 by 1 plus 0. 6 infinity is equal to infinity only. 6 into infinity is also infinity. Multiply with any number with infinity, that goes to infinity only. Fifth one, limit x tends to infinity e power minus x square. That is nothing but here also we can take limit x tends to infinity e power minus x square, means that should be right in the denominator, e power x square in the denominator, that is 1 by e power x square. It is equal to 1 by e power infinity square, that is e power infinity, it is equal to 0. Why? Because e power infinity equal to infinity, e power minus infinity equal to 0. Why? Because 1 by e power infinity is 1 by infinity, 1 by infinity is 0. Sixth solution, limit x tends to infinity under root of x square plus 6 by 2x square minus 1. Here also, if the infinity is there, then we can taking the common of the highest ratio, highest power of the x or highest ratio of the x. Under root of x square common 1 plus 6 by x square by x square common 2 minus 1 by x square. It is taking out of the under root, that is limit x tends to infinity x under root of 1 plus 6 by x square by x square into 2 minus 1 by x square. 1x cancel. It is equal to limit x tends to infinity 1 by x into under root of 1 plus 6 by x square by 2 minus 1 by x square. It is equal to 1 by infinity into under root of 1 plus 6 by infinity square by 2 minus 1 by infinity square. It is equal to 0 into under root of 1 plus 0 by 2 minus 0 equal to 0. In the second bit, the first problem is limit x tends to infinity 8 mod x plus 3x by 3 mod x minus 2x. The solution is x tends to infinity means that is nothing but x is a positive value, then only it tends to infinity. So in this, the mod x we are taking x only. Why? Because x goes to infinity. On the number line, when it goes to infinity, the positive side, the x values are changes to positive side. So the condition is x greater than 0. When it is greater than 0, we can take the relation mod x is equal to x. So limit x tends to infinity 8 mod x plus 3x by 3 mod x minus 2x. It is equal to limit x tends to infinity 8x plus 3x by 3x minus 2x. Simplify it. Limit x tends to infinity 8x plus 3x is 11x by x. X get cancelled. We are getting the 11 is a constant. So in the no x term, no x variable. So it is the limit value. Second solution, here the same as usual of the before problems only. In this, x square common in the numerator and x square common in the denominator, 1 plus 5x by x square plus 2 by x square by x square into 2 minus 5x by x square plus 1 by x square. Here x cancel, here also x cancel, x square cancel. You can apply the infinity. If x tends to infinity, then 1 by x tends to 0, or 1 by x equal to 0 when we can substitute. That is 1 by infinity is 0, and also 1 by x square also 1 by infinity square is also 0. So we are getting limit x tends to infinity 1 plus 5 by x plus 2 by x square by 2 minus 5 by x plus 1 by x square. These terms goes to in zeros, so the value is 1 by 2. You can simplify just what we did in the before problems. Here also the same thing, x tends to minus infinity means then 1 by x is nothing but 1 by minus infinity. It is minus 0 means 0 has no sign, so it's 0. 1 by x square also 1 by minus infinity square, it is also 0. So x square common, that will get cancelled. The constant terms are 2 by 1 equal to 2 is the limit value of this. You do that homework. Okay. Fourth one, in the numerator x cube common, in the denominator x cube common, then we get the constant term is 11 by 3. So it is the 11 by 13. 11 by 13 is the limit value. Why? Because when x tends to infinity, the 1 by x value is 0. 1 by x square value is goes to 0. So x cube common, x cube terms are get cancelled, then 11 by 13 is a constant. So limit value is 11 by 13. You do fourth one also. Why? Because that is similar to previous problem. Next, fifth solution. Here limit x tends to 2. When we can substitute in the denominator, it goes to infinity, but we cannot apply. Just first of all, we can simplify it. 1 by x minus 2 minus 4 by, it is in the form of a square minus b square, split into factors, x minus 2 into x plus 2. And taking the LCM of given two terms, here x minus 2 already is there, the absent of x plus 2 minus 4 by x minus 2 into x plus 2. It is equal to limit x tends to 2, it is x minus 2 by x minus 2 into x plus 2. Here x minus 2 factor will get cancelled, and now we can apply the limit value of x, that x equal to 2 plus 2. This is equal to 1 by 4. It is the limit value. Just you can check it. Is it simplified or not? If it is not simplified, then you can simplify it and then you can substitute. Sixth solution. Here also same like the previous problem only. In the numerator, we can take in common x cube, that is 5 plus 4 by x cube, by in the denominator x to the power of 4 common in the under root, 2 plus 1 by x to the power of 4. After that you can write it outside, limit x tends to infinity x cube by x square into 5 plus 4 by x cube by under root of 2 plus 1 by x to the power of 4. Here x square, x cube get cancelled. If x tends to infinity, in this 1 by x tends to 0 and 1 by x cube tends to 0, or 1 by x to the power of n, whatever the power is there, that 1 by x power anything, it should be 0 after the substitution of x equal to infinity. But here in the numerator infinity is there, infinity into 5 plus 0 by under root of 2 plus 0, it is equal to infinity only. Okay, that is the sixth one. The seventh one is, if it is minus infinity, then we can substitute minus infinity, then it should be minus infinity. If it is plus infinity, then we are getting the plus infinity. And the seventh and the eighth both are the similar to one to another. Why? Because it is in the numerator, in that no common. In that case, we can take the rationalize of the numerator term. Okay, that is limit x tends to infinity root of x plus 1 minus root x. Now we can take the rationalize root of x plus 1 plus root x by root of x plus 1 plus root x. Here it is equal to limit x tends to infinity a minus b into a plus b, a square, that is root of x plus 1 whole square minus root x whole square by root of x plus 1 plus root x. It is equal to limit x tends to infinity, square root to cancel, square root to cancel, it is x plus 1 minus x by root of x plus 1 plus root x. X cancel, it is equal to limit x tends to infinity 1 by root x is taking common, 1 plus root of x plus 1 by x, that is equal to limit x tends to infinity 1 by root x into 1 plus under root of 1 plus 1 by x. When we can take the x tends to infinity, then 1 by root x also 1 by root infinity is infinity, it goes to 0. So this is equal to 0 by 1 plus under root of 1 plus 0. It is equal to 0. Eighth one, you can do that by the same thing, the rationalize. What is the rationalize? Limit x tends to infinity under root of x square plus x minus x. Rationalize of the numerator means taking x square plus x plus root x by under root of x square plus x plus root x. Limit x tends to infinity root of x square plus x whole square minus here only x, here also only x, minus x whole square by root of x square plus x plus x. is equal to square root to get cancelled, limit x tends to infinity x square plus x minus x square by taking common x square, that is x square into 1 plus x by x square plus x minus x square plus x square cancel, limit x tends to infinity x by, here under root of x square is taking outside, x under root of 1 plus, here x cancel, 1 by x plus x. X is taking common in the denominator, limit x tends to infinity, x by x into under root of 1 plus 1 by x plus 1. X cancel. Now we can substitute the infinity value, that is 1 by under root of 1 plus 1 by infinity plus 1. It is equal to 1 by root 1 plus 0 plus 1. Root 1 is 1. It is 1 by 2. It is the solution.